Yeah, great. All right. Welcome. Good evening, everyone. All of our participants. Oh my God. All of our participants. Welcome to TLE's DS404's last session. And we're glad you made it through us through the past 4 sessions and listened to our speakers patiently and understood concepts as Vishruth, Pranay, Pranav, and Gautam took you through the entire world of data structures. As always, if this is your first time here, a quick walkthrough. This is DS404, the series of data structures based on the basic things you should be knowing in coding, conducted by a collaboration with TLE MEC and TC. And if you reach out to us soon, we can also go about conducting sessions like this in the future. And with that, I think we'll move on to what this session is truly about. So we started this with Vishruth, and so it seems fit to end it with him as well. Last but not the least. And yeah, Vishruth Subramanian, the chair of TLE MEC, will be starting the session. I'm just not going to let him start. Yeah. Very well. Vishruth, you can carry on. Yeah.
Thank you, Sharath. So hi everyone, welcome back. And yeah, so first of all, congratulations on making it all the way here over the past 4 sessions. And this is the last session. So actually the previous session was supposed to be the last session, but then, I thought, like, since you all learned all this, we could just do one more session, which is about problem solving. And also I started this whole thing, I got you all into this mess. So, but I'm not going to get you out of this mess. We are just going more into it. But anyway, so this is about problem solving. So unlike the previous sessions where the speaker will teach and all of you will be listening or on Instagram, here you will be doing most of the work. It's just purely problem solving. So we'll have questions, coding problems, and other MCQ type problems as well, which we can solve it together. So shall we start? Can you all be active in the chat like you were first? Just type something. Anything? Yeah, cool. Okay, right. Okay, so yeah, let's rewind. So since most college students have short-term memory loss, okay, before that, let me ask you, how many of you remember whatever you've learned so far, like time complexity, arrays, stacks, queues? Just put anything in the chat if you remember anything about what you have learned so far over the past 4 sessions. Nobody? Okay, something. Yep. Almost, yeah. There are so many of you here, so all of you should type. If you don't know, type no problem. Okay, thoda. Okay, okay. So first, I'll just give you a quick recap of the things that was learned. A very good Tom. Okay, so first was about time complexity, which was taken by Vishruth. So that is, so time complexity is basically the amount of time taken by an algorithm to run as a function of length of input. So suppose, okay, yeah. So suppose we have, you learned big O notations and all, like big O of n, big O of 1, etc. So if I have a code like this, for I equal to 0 to n, some statement say print, then the time complexity of this is order of n, because it goes from 0 to n. Similarly, also, like when we are given a function, say 3n square plus 4n plus 5, can you say what's the time complexity of this? Do you all remember this function? Yeah, n square, good. So this would be O of n square. So yeah, just the basics. And I think all of you remember. Anyway, the next was about arrays. So arrays are like for storing same type of data. So imagine you have a class, you have like 60 or so students, and you need to store the marks of them. So one way to do it would be to declare 60 variables and store mark of each student. But then that is very inefficient. So instead of that, we have an array, which is like, it stores data continuously. and you can store, like you can create an array for marks and then store the marks, all of them continuously. So, and it can be accessed using the index. And can someone tell what's the time complexity for accessing an element using the index of an array? So for example, if I type ARR of 1, it is 1. Yeah, it's constant. Great. Okay, so that is about arrays. And then we have stack. So stack is the last in first out data structure. You push elements into the stack and you pop it. So it is like this, tennis ball thing where you can only insert from one side. So the last element that is pushed gets popped out first. Okay, if you have any doubts in whatever I'm telling right now, do ask, because I'm going a bit fast because this is something you have already learned. So, and this is about problem solving, so we'll get there. So if you have doubts, do ask. And then, yeah, we have queue. So queue is the first in first out data structure. This is just like a real queue that you see. So you have a front and a rear, and elements are inserted in the rear and they're removed from the front. Okay. So do you have any doubts on time complexity, stack or queue so far? If you do, please ask it in the chat. Okay. Okay, do you have any doubts, anyone? If not, then we'll continue. So the next part of this would be some problems that are like MCQ questions. So before that, I would recommend you have a book and a pen so that you can work them out. Some questions, it would be better that you can work them out. So can you all take a book and a pen and then put some random emoji in the chat so that we can go ahead once you have a book and a pen. There was a question regarding how to create a queue using 2 stacks. Okay. I think that, yeah, that was for the contest, I think. Okay, that question I'll take it up in the end, okay? The stack and queue question. Yeah, right now let's, okay. Okay, yeah, you all have a book and a pen. So, take your phones and scan this code. The thing is, like, instead of putting the answers in the chat, you can directly put your answers there on your phone itself. Or if you don't want to use your phone, go to this link and type that code. I'll put the link here. It's yeah. Just scan this code, everyone, or go to the link and type the number. All of you here, please do it so that you can see your answers. You can, and please do type your name, type your full name there. Don't type a random name. Type your full name because we have a leaderboard soon. There are 60 people here. I'll wait for 5 minutes I'll wait. Just all of you, please join. If you have any doubts, if you have facing any issues in joining, please ask in the chat. Okay, who is this smiley face? Ramana. Join people. Okay, Kushi is the smiley face. $20.51. $36. Okay. All of you, please join. If you have any issues in joining, put it in the chat so that I can know. 40. Once it reaches 55, I'll start. The rest of you here, please join fast. I'll start this at 6:20. And if you have any trouble in joining, do let me know. 56. ബാക്കിയുള്ളവരൊക്കെ ഓൺലൈൻ ക്ലാസ് പോലെ ഇവിടെ ഓണാക്കി വെച്ചിട്ട് പോയേക്കുവാണ്. പ്ലീസ് ജോയിൻ ഹിയർ. Okay, I think I'll just start. I don't know why these people haven't. Is there anyone who's facing any issues with joining? Please type in the chat. Like if you have some kind of issue, network or something, then let me know. Or I'll just start now. Okay, the questions are timed. Okay, 60 seconds for some questions, and the little longer questions have 75 or 90 seconds. So you can select your option over there, but some questions you need to refer my screen. That is this screen, because some questions like the code questions, it can't be typed over there. So that I'll tell you. The rest of them you can see the questions on your the phone or the computer itself, and mark your option and click on send. Okay, so I'm going to start this. Okay, are you all ready? Type something so that I'll start. Are you all ready? Okay, cool. Okay, I'm starting. So the first question, you can select your answers on your device and make sure to click on send once you have selected your answers. And it's 60 seconds, so yeah. Answer fast, you have 30 seconds. The rest of you answer fast, you have 10 seconds. Make sure to click send, okay, everyone. And then I'll explain the answer. Okay, so most of you got it right. Okay, I'll explain this. The first thing, time complexity of binary search is order of log n, it is not order of n. Stack is LIFO, Q is FIFO, and then time complexity of NQ and DQ is order of 1. It is constant time. So in a queue, you have a front and a rear. So since you have both of these variables, you are just when you delete from the front, you just modify the front, and then when you delete from the rear, you just, when you insert into the rear, you just add the rear. So in both these cases, you're not iterating anything. So it is constant time. Okay, I hope that is clear. And then yeah, 5 elements can be inserted. So ARR of 5, it's ARR of size. So 5 elements can be stored in an array declared as ARR of 5. Okay, I hope that is clear. Next question. Okay, for this, just refer my screen. This question, refer my screen. You can see the code on my screen. I hope it is visible. Yeah, can someone from TLE confirm that it's visible? Tom or anybody? Code.
Yeah, it's visible. It's visible.
Right. Yeah, so you can mark the answers on the This has also time 30 seconds left. All of you, please answer. 33. There are 49 of you who have joined. Those who have just joined, you can go to this QR, scan this QR, and you can still participate. So, okay, cool. Let's see. Okay, most of you got it right. So the answer is order of n plus m. See, this loop runs from 1 to n. So this loop has a time complexity of n, and then this loop runs from 1 to m. So this has a time complexity of m. So when you, and these are not nested loops, they are two separate. So if they were nested, then it would be the product. But here, since they are separate, it is order of n plus m. Okay, I hope that is clear. If you have any doubts, you can ask. Otherwise, I'll go to the next question. Yes, so simple question on time complexity. No, there is no negatives. You can mark. There's no negatives. Yeah. Okay. Here's the next question. You have 60 seconds, so do this fast. Come on, answer. 30 seconds left. Oh. Okay, this was an interesting question. So 70% of you answered option A, but the answer is option D. The reason is that you may have forgotten this first sentence. Max size is, oh wait, max size is 5. So I'll just explain this. See, here you have a stack of max size 5. So, and then, so you push 12, you push 8, and then when you pop, this 8 goes, and then you push 5, push 16, push 30, and then you push 22. 50 doesn't get pushed because the stack has reached its size, maximum size. So this push 50, it doesn't get pushed because of this max size is 5. Okay, so I think that's where you may have made the mistake. Okay, I didn't explain the output now. Initially we push 12 and then we push 8, and then when we pop 8, 8 gets print. Oh wait, there's something wrong. Oh, no. I am so sorry, the options were wrong. It was supposed to be 8. The output is, let's see what the output is. I'm so sorry for this. The options got messed up. Anyway, so first you push 12 and then you push 8. 1 second. I'm so sorry again. So first you push 12 and then you push 8, and then when you, okay, the question asks what's the state of the stack. Okay, so you push 12, you push 8, and then you pop 8, and then you push 5, push 16, push 30, push 22. 50 doesn't get pushed, and then you pop 2 elements, so 22 is gone and 30 is gone. So the remaining elements in the stack are 12, 5, and 16. So that is option D. Okay, is that clear? Anyone? Do you have any doubts? Yeah, so it is 12, 15, 60. And the reason many of you got the first option is because you may not have considered this size. Okay, so next question. Yeah, this is a easy question. Twenty seconds left. Make sure to click send in your answers. Those of you who just joined, you need to click send only, then it will get sent. And also the scoring is based on the time also. So you can answer first, don't wait till the end if you have already marked your answers. Okay, so great. Yeah, most of you got it right. So regarding an array, it's used to store the same data type. Elements are not stored randomly, they are stored in consecutive memory, and elements can be accessed using index. Indices start from 0, not 1, and then time complexity is constant. Okay, so that's just the basics of an array. Next question. Yeah, this one, the code. 1 second. Yeah, this is the function, and you have 80 seconds to answer this. Twenty seconds left. Should we ignore? No. The for loop is there, right? That's also there. That's also part of the code. Okay, let's see. Yeah, most of you got it right. So I'll tell you how this works. So initially the array is, let's see 1 second. Okay, so initially the array is 1, 2, 3, 4, 5, 6, and then the indices are 0, 1. Indices of the array start from 0. So 0 and 5. Okay. Now, when you have questions like these and it is timed, you can easily eliminate the remaining options. So when you see here, ARR of 1, ARR of 0 is not being modified anywhere here. So in all the other 3 options, you have 6 coming first, which is not possible. So just by looking at this code, when you see that ARR of 0 is not modified, you can directly mark the first one as the answer. Okay, so that will save you time. But anyway, I'll just explain this. So ARR of 1 is this element, and it gets incremented by 5. So 2 plus 5 is 7, and this becomes 7. Next, ARR of 5 is ARR of 1 minus 4. So the fifth element is 7 minus the fourth element, which is 5. So 7 minus 5 is 2. This becomes 2. And then the loop runs from 2 till 5. which means 2, 3, and 4. And the elements get multiplied by 2. So this becomes 6, this becomes 8, and this becomes 10. And 1 is same as 1. So this is the answer, the option A. Okay, is that clear? Type something in the chat. Okay, cool. So yeah, if it's something timed and you have to answer, then as I said before, you can just notice that the first 0 is not modified anywhere. So directly mark option 1. Okay, so we'll go to the next question. Okay, next is 3. This also has 90 seconds time, so take your time and write. Work these out in a book. It will be much better than just trying to do it mentally. "30 seconds left. Do answer." "10 seconds." Okay. Oh, great. Most of you got it right. So it is 5-1. Let's see how it is 5-1. So these type of questions would, test your understanding of how all these arrays, stacks, and queue works. So here, okay. Initially, we have an array ARR which contains 5 elements. So ARR would be 1, 2, 3, 4, and 5. Okay, and the indices are from 1. Is anyone saying something? If yes, then I can't hear, or just mute if you're not saying anything. Okay, so yeah, this is ARR, and then stack and queue just creates an empty stack of 5. Now S dot push ARR will, okay, so we have a stack S, and ARR of 0 is 1, so 1 is pushed into the stack. And then we push ARR of 4, so ARR of 4 is 5, so 5 is pushed into the stack, and now this is the top of the stack. So whenever you are doing questions on stack, like output or something, draw the stack like this so that it's easier to see what is on the top. And T is S dot top, so we have T here, which is 5. S dot top is 5, so the top of stack is 5. Okay, now we have a queue. So I'm taking a queue like this, and we are inserting, NQ is the insert, so we are inserting T into the queue. So T is 5, so 5 gets inserted at the rear, and initially both front and rear are at 5, and you're inserting ARR of 1, which is 2, also into the queue. So the rear becomes 2 and the front is 5. Okay, and P is Q dot front, so P is 5, and S dot pop, so we are popping the stack. So 1 second, yeah, so when we pop the stack, 5 goes and the top becomes 1. If you have any doubts in anything I'm saying in between, you can ask in the chat. Okay, so this is the top right now, and in R we are storing S dot top, so 1. And finally we are printing P and R, so P is 5 and R is 1. Is that clear? If I went too fast, just let me know. But yeah, just so when you get questions like this, first take the array and you can mark the indices and all. And then when you do stack, draw it like this so that you can easily identify top, and queue you can draw it like this because you insert from one end and remove from the other. Okay, so this was a simple question to test your knowledge on all these three. Okay, I'm going to the next question. This is again a question on queue. This is a simple question. Thirty seconds. Okay. Okay, most of you got it right. It is 5, 6, 7 and underflow. So I'll explain that. So here you have a queue. It's an empty queue. I'm calling it queue. And then we insert 5 into the queue. We insert 6 into the queue. So this is the front and this end is the rear. So we insert 5, we insert 6. And then when you dequeue in a queue, the element that comes first goes out first. So here 5 came first. So 5 is going out first, and here DQ, assume that DQ prints the element. So first 5 is printed. So 5 gets printed and 5 is removed. And now we are inputting 7. So yeah, we are inputting 7. Now when you call this DQ, the element that came in first is going out first, or the element at the front is going to go out first. So the 6 goes out and 6 is printed. And then again, when you call DQ, 7 goes out and 7 is printed. And then when you call DQ here, the queue is empty. So when the queue is empty, we get an underflow. So it's 5, 6, 7 and then underflow, which is the option D. And then NQ 8 is inserted, but we are not printing it. So this is 5, 6, 7 underflow. I hope that was clear. I'm going to the next question. If you have any doubts, do ask. Okay, next question. Next one. This is a challenging question. "25 seconds left. Do answer fast." Oh, wow. All of you most of you got it. Answer is G. This was 2, right? Yeah. Okay. So you have two queues, Q1 and Q2. Q1 and Q2, which are initially empty. Suppose A, B, C, D are inserted into Q1. So A, B, C, D, and E are inserted into Q1. If any of you have any doubt when I'm explaining this, you can ask in the chat. Okay, if I'm going too fast. Anyway, so we have 5 elements A, B, C, D, and E that are inserted into Q1. Now from this, 2 elements are removed and inserted into Q2. So when you remove from the Q, you remove from the front. So here A and B are gone and it is inserted into Q2 in the same order. Like A comes first and then B. 2 new elements F and G are inserted into Q2. So here we have F and G. And 3 elements from Q2 are removed and inserted into Q1. Okay, so A is removed first, then B, and then F. Finally, 1 element is removed from Q2 and that element is G. So the answer is G, option B. And most of you got it. Those of you who didn't get the answer, is this clear? If there's anyone who didn't get the answer, or is it clear? Like, if you didn't get it, it's totally fine. If you have any doubts, you can ask. So yeah, the questions like these, you just simulate the queue and insert the elements as it is given and then get to the output. Okay, I'm assuming it is clear. So we'll go to the next question. Are you all here? This is the next question. Refer my screen, okay? EX5. This is also on stack and array. Answer fast. For those of you who haven't, make sure to click send on your answers. Okay. So one more thing. There are 54 people who have entered the quiz, but only 35 are answering. So the rest of you do answer this. There is a leaderboard at the end, and you can also see your scores and all. So yeah, this question, next slide. Okay. So array is 1, 2, 3, 4, and 5. And we have a stack S. And all the elements of the array are pushed into the stack. So here 1, 2, 3, 4, and 5 are pushed in this order. And then we create a new array. This is ARR1. And we have ARR2. Okay. And starting from the 0th index, we are just taking the top element. So here S dot top will give 5, and then 5 is stored at the 0th index of ARR2. Then we have 4. Okay, 5 is gone, 4 is gone, and then 3 is popped and stored here. 2 is popped and stored here, and finally 1 is popped and stored here. So this basically reverses the array. When you use a stack, you can use it to reverse an array. So this is the code for that. You create a new array, and then you get the array which is the reverse of the original array. Is this clear? Yes? Anybody? Okay. All right. So next question. I think, yeah, this should be the last question. Okay, great. The answer is B. Most of you got it. 7% of you. Some of you got C, some of you got D. Let me explain. Yeah, this is, I think, the last question. So here we have a stack, and it's mentioned that these elements are inserted in the reverse order, that is starting from G. So the elements are inserted like this: G, F, G, F, D, C, B, and A. Okay, and this is how the stack looks. Then the stack is popped 5 times and each element is inserted into a queue. So, oh, I missed the, sorry. 1 second. Erase this. Okay, so here we have G, F, E, D, C, B, and A. Okay, now 5 times. So when a stack is pushed, this is the top. So the element at the top is pushed. So A is gone and it is inserted into a queue. And then, okay, B here. A is gone, B is gone, and it is inserted into a queue. C, similarly, C, D, and E. Okay, 5 elements are popped and inserted into the queue. Okay, I hope that is clear. Now the stack is F and 2 elements in the remaining in the stack, which are F and G, and this is how the queue looks like. Okay, and what else? 2 elements are deleted from the queue and pushed back onto the stack. So always in a queue, deletion occurs at the front. So A is gone first, A is removed first and inserted here, and then B is removed and inserted into the stack. Now one element is popped from the stack. So this element is B, and the answer is B. Okay, I hope that is clear. Yeah. Any doubts on this? Anybody? If not, then we'll move on. I think this was the last question. Okay. Okay, so let's see who won. Joshua. Congratulations, Joshua, and then George and Kevin. On which class are you? Type your class also in the chat so that I know. All these 3. George, I know. Kevin also. Kevin and Joshua. CSA. Okay. Nice. And Aldrin also. Congrats, Aldrin. The rest of you, you will be able to see your I think you can see your score there. So just you can go through that. So this question was the hardest. Okay, yeah, this was because you may have missed the max size. All right. Okay, so was this interesting so far? Tom got 36. Congrats, Tom. Okay, so yeah, this was based on stacks, queues, and arrays for testing. Now let's go into code, like coding problems. So, okay, try this question. This is the question. It's a coding question. So just read the question and type anything if you understood the question. If you didn't understand the question, you can ask your doubt. Is this no, you can close Slido. Yeah, the Slido thing is over. You can close that. Now it's just coding questions. So yeah. Okay, this is a question. So if you understood the question, put anything in the chat. If you have a doubts on the question, then you can put the doubt in the chat. I'll give you some time to read through it and try to come up with an approach to solve this. Okay, I'll provide some more examples maybe. Let's see. Before that, one more thing. All of you, please change your chat to, you can set it to DM me instead of everyone. So at the bottom, you can send it, you have a to everyone. Instead of that, click on that and send it to me so that first I can see your answers, but let everyone come up with their approach also. So when you send your answers, send them to me as a DM in the chat. Okay. Yeah, so we iterate through the array, we consider all elements and then write the smallest. Yeah, that is correct. So that works. Okay, now try to think of like an algorithmic way. Convert that. Also, all of you, please, all of you can type your approaches because this one of them may not be the correct one, and also there's more than one way to solve this question. So I'll give you 5 minutes. Think and type your approach in the chat as a DM. Okay, so yeah. If you have any doubts in the question, you can ask. Could you explain the question? Yeah, sure. See, we are given an array. Okay, so in this example, say 6, 4, 5, 3, 7, 1, 8, 2. Okay, for each element, we need to put in the smallest element on the left side. So when you consider initially for 6, there is no element on the left. So the minimum smallest element is 0. For 4, the smallest element on the left side, what is that? You don't include that element. You just consider all the elements on the left of 4. So that is 6. Only there's just one element, which is 6. Now, when you consider for 5, you just see the left side. So yeah, you get 4. And similarly for 3, the smallest element on the left side is out of 6, 4 and 5, the smallest is still 4. So when you consider for 7, the smallest is 3 and so on. So you get this array. I hope the question is clear. Is the array going to have positive integer? Yeah. For this particular example, you can take, okay, I didn't mention that, huh? Array, all the elements are positive. So 1 greater than or equal to ARR of I, greater, sorry, 1 less than or equal to ARR of I, less than or equal to 10 raised to 4. And the size of the array is again from 1 to 2 into 10 raised to 4. Can we use nested loops? Yeah, sure, no problem. I just need a solution. And okay, Kevin has sent a solution for I0. Yeah, Kevin's solution. There is a slight something wrong with your solution, I think. J less than J plus 1. 1 second. Let me see if your solution. The others you can put your approaches. Yeah, Kevin, yeah, that's the mistake. So just correct that. The rest of you do attempt it and just type anything that comes to your mind in the chat, like how you're going to solve it. I don't want code and all. And even I don't need the algorithm. First, you can type the like the approach. Yes, Sri Priya's answer is correct. If J less, no, wait. Sri Priya, if J less than S. Okay, when you put SS0 and all the elements are greater than 0, so J less than S doesn't work. Sri Priya KS. I mean that condition never becomes true. So the output for your answer would be 0, 0, 0, 0, 0. Okay, John Abhinav first 0, then variable, iterate through each element if just is smaller than element. Okay, Abhinav, I think your idea is correct. Yeah, Fahim's answer is correct. I minus 1 less than smallest. Yeah, Fahim's answer works good. Print 0 for I less than n, for j less than or equal to I, t is ARR of j if ARR of. Yeah, part of your answer is also correct. That will also work. Good. J. Also, no. In Parthiv's answer, J should not reach I. It should be less than I, because it should the ith element shouldn't be included. The rest of it is fine. And Abhay, define a function that finds smallest number. Yeah, that's correct. When you type your answer, please type the whole thing, because if you type a separate messages, I get other messages in between, and yeah, so just yeah, try to send as a single message, because okay, Sri Priya. Yeah, now Sri Priya's no Sri Priya's answer, J from 0 if J less than S, L1 dot append S. No, there is a slight issue with that, because each time you are appending S, you're not changing S anywhere now. So the first J that satisfies the condition gets appended, and all those elements that are smaller than S gets appended. We don't need that to happen. You just need the smallest one to get appended. Okay, wait. Vismaya, iterate AN to 0. Yeah, that's correct, Vismaya. The logic is correct. Okay, I'm going to discuss the answer now. Most of you got it right. Your approach, there are slight mistakes here and there for some people, but otherwise the idea is almost correct. So let's see. Okay, so I'm gonna start the answer. Okay, so now you can all put your messages back to everyone, and I'm gonna discuss it. So here we are. Is there anyone who didn't understand the question or any part of the question, or can I discuss the answer? Type anything. Are you all here? Yeah, okay. എല്ലാരും ഉണ്ടോ? ബാക്കി എല്ലാരും ഉണ്ടോ? ഇത് ഓൺലൈൻ ക്ലാസ് പോലെ ഇട്ടിട്ട് പോയേക്കാണോ കുറെ പേര്? എല്ലാരും ഉണ്ട്. Okay, കൊള്ളാം. Right. So here, what most of you said was correct. So we need to generate this array, right? So initially we can print 0, and then for each element you will iterate to the left of it, to the left of that element, and find the smallest. So we do something like this. For I starting from 1 all the way till n, you need to find the smallest from 0 to I, or I to 0, doesn't matter, the order doesn't matter, and then print the smallest element. Okay, this is the logic. This is what most of you said, and it's correct. So, and then you implement this part. So this part is just finding the smallest element in an array, where instead of so when you find the smallest element in an array, what do? You go from 0 to n, but here instead of that you just go from 0 to I. So how do you find the smallest element in an array? So initially you initialize a variable called small. Now many of you initialized it with 0. This is not right, because whenever you have when you have to find the minimum of something, you don't initialize it with 0, because then all these values, like when you compare the smallest value, the 0 will always get printed. So usually what we do is we initialize it with infinity, positive infinity. So in C++, it is int max. If you're using Python, it would be like a float of infinity. Float infinity. This is the general thing used whenever you have to find the minimum of something and you don't know the range of the values or anything. So in those cases, when you have to find the minimum, you initialize it with infinity. If you have to find the maximum, you can initialize with int min. That would be negative infinity. Okay. So you just initialize small. Now in this case, yeah, initialize it with the smallest. Then what do you do? For each element, for say j equal to 0 to n, let's say we are finding the smallest element of this entire array. So then you do for j equal to 0 to n, what do you do? If the current element, if ARR of j is less than the smaller is less than our current small element, then we just update the value, right? We update small as ARR of j. And finally, you print the small value. Okay, is this clear? So this is from 0 to n. Instead of that, in this case, we go from 0 to I. So this entire thing comes inside this. So I'll just write the code. I'll write the code in the next slide. So is this logic clear? What we do is for every element, we iterate the array back up to that element and find the smallest. Okay, now some of you, what you did was you compared ARR of j with ARR of j minus 1. So that doesn't work because you need to compare it with the smallest. And then another mistake some of you did was you didn't update the small value. So here, if you just print it, what happens is all the elements that are less than the smaller value gets printed. So that is not to be done. At each step, when you find the small, you update the smaller value. Okay, is this clear with everyone? Put something in the chat. Because if you have any doubts, put that, because only after this in Python you can use the min function for int. Yeah, that code works, correct. You can do this in Python in one line actually. I mean, yeah, you can do that. That works. I'll show you the code. Yeah, Kevin, that works. Good. Okay, here I'm just explaining the logic because one more thing I need to explain. So, okay, is this clear with everybody? Just type anything in the chat, people. I'll just make, okay. Okay, I'll write it clearly. So how this works is for I equal to 0, I less than n, I plus plus. Okay. Here what you do for initial, okay, for I equal to 1, initially it is 0. You can, okay, I'm going to call this output as result array. Let's say we have a result array. So result of 0 is 0. And then we start from 1. Okay. So let's say we have a resultant array. And here I plus plus. Now what do? You initialize a variable small, which you can either also, you can put it as, here, if you don't want to put it as infinity, you can also put it as, no, here in this case, we'll just put it as minus, infinity, because we'll be comparing. So, and then what you do for j equal to, here you can go from 0 to I or I to 0. It doesn't matter which order you go. So here, let me try going from I minus 1. I'm going all the way backwards to 0 and I'm subtracting. And if, now I wrote here previously, I wrote if small, if ARR of j less than small, then small equal to ARR of j. Okay. A shorter way of doing this is you can just write it like this. In I think both Python and C++, you can do it like this: small equal to min of small comma ARR of j. Just one line like this. What this does is it will take the smaller value among these two and put it in small. So essentially this entire block of code is done in one line like this. So here, instead of using the if statement, I can just write this one line. Okay. Small equal to ARR of min of small comma ARR of j. Okay, and this loop ends there. And then outside this loop, we have the smallest value. So we can, since we are printing another array, we can do rest of I equal to small. Okay, so this would be our answer. And then you return the array, return rest. Is this clear? If it is clear, type the time complexity of this code that I've written here. What would be the time complexity of this code? Anybody? All of you can type your answers. N square, N square. All of you are saying it's N square. Any other answer? All of you type your answers, please. same answer anengilum just type it so that I know you people are here. Everybody, there are 52 people here still. Unless you have gone elsewhere, type your answer n square. Okay, good. So n square, right? N square is not very efficient. Okay, this code is correct, but it is not efficient. So yeah, the time complexity of this is n square, order of n square. And in most cases, as I told before, this array has input size of the order of 10 raised to say 4 or 5. In these cases, you will get a TLE for this if you write this algorithm or this code. And even that Python one-liner, the one where you do min of this, internally that would run this loop. When you use that slicing, it will find that list from I to j, and then from 0 to that I, and then take the minimum. So that will also give you a TLE. So can anyone come up with a solution that is more optimized than this, that is without the second loop? Can we give small equal to ARR of I instead of infinity? No, because if we give that, then take for example in this case, if you give small as 1, so initially small is ARR of I, and when you calculate j for all these values, 1 will remain the smallest. So you will get 1 1 1 1 1 like this. You will get 1 as the output for 1, which you can't have ARR of I itself. So that is why we gave int max in this case. Okay, I hope that is clear to see. Whoever named themselves C in Zoom, maybe you should upgrade to C++. Anyway, Abhinav's code. Can we do this? Okay, now you all can put your change your messages back to everyone, because let everyone can see, because we are discussing the answer. So all of you just think of some way by which you can get rid of the second loop entirely. Okay, I'll give you some time, 5 minutes to think. In the meantime, let me just read the chat. Can we do this with stack? With stack. Yeah, with stack we can do it. Pop the elements that we've gone through. Can you elaborate? Can you give me an algorithm for that? Also, like, I don't think stack is necessary. Anyway, yeah, that you can try writing an algorithm for that. Okay, Abhinav's code, that only compares the first element before, right? So that won't work. Because see, suppose in this case, for 1, you just compare it with 7. The remaining elements are not considered. So that will not work, Abhinav. Actually, let me just go this. You can try your approaches. I'm just going to code the solution that we just saw. Smallest is stored in a variable, so we can compare previous. No, when you compare it with the previous element, what about the other element? Okay, previous element. Okay, give me the correct code for that. This current code doesn't work. The one that you just gave, I am not sure if it works. Let me, you know what, I think I can copy paste this now. And we can test it out. Okay, just give me 1 minute. I'm gonna code it and see. Yeah, Joshua, if in an array, encounter a smaller element, only then store it. That will work. Yeah, so can you code, give me a code for that? So 64431. Okay, yeah. So this is the code that we saw first, the algorithm, and this gives us the correct output. Okay, now this is in C++. So yeah, Syam, that code works, the one you wrote in Python. When you slice it or when you sort it, all that takes linear time internally. Like it will inside the loop. So it is like, or it's still order of n square when you slice or sort. Not sure, but from for I equal to, yeah, that'll work. Okay, Aldrin, what? Yeah, n log n, correct. That'll work. Good. You got it up till n. No, wait. Okay, no. Aldrin, that time complexity won't be n log n. It would be, it's not n log n. Just think. And now you can put your messages to everyone. So let everyone can see like the different approaches. Because, yeah, Aldrin, it's not n log n. But the answer works, but it's not n log n. For from I to 0, if I is small, smallest array. Oh, okay, this seems promising. Aldrin, can you did you like tell me why it is not n log n? Sorting best case log n alla. Sorting the time complexity log n alla. Binary search and log n. Sorting is n log n. Whatever sorting you use, the library ones, it's n log n. It will become n square log n. I mean, yeah, n into n log n, which is n square log n. But still, you will get the answer. You just went from bad to worse. Okay. This one. Whose solution was this? Joshua. So what is S here? Joshua? New array. Okay. So can I replace this with print small? Or do I need this S? Okay. see if this works. So small was not, oh, okay. What is the initial value of small? Outside this loop, I'll put it as infinity. Uh, 0, 6. Okay, here it will be from 1 then. Okay. 0, 4, 4. Not will be from 0 itself. Initially, you print 0 from 0. So, but then there is an extra. Okay, 6, 4. But an extra വരുന്നില്ലേ? Yeah. One second. Till n-1, don't consider last. Work out. 0644331. 0644331. Okay, what about if I give 1, 2, 3, 4, 5, 6, 7. Okay, Kevin solution int max small greater than Allah. Kevin, small less than Allah. Small less than, yeah, that will work. I think so. Let me just check. Yeah, this one works. Joshua's is correct. All of you can type your code in the chat if you want me to test it out. I'm gonna tell the answer now. I mean, yeah. Okay, so I'll just discuss the answer now. See, here in the previous case, so okay, wait. We have 6, 5, 4, 5, 3, 7, 1, 8, and 2. This is small having max value. Initially having, I didn't get you. No, yeah, it has max value. So when you compare it, it should always be less than whatever. Okay, yeah, sorry, that was correct. Okay. You put small greater than ARR of j-1. Yeah, that's correct. I thought it was the other way around. So ARR of i-1 less than small. Yeah, same thing. Okay, so here, okay. See, here we have this array, and what we are going to do is initially I'm going to keep track of the minimum so far. Okay, I'm just going to iterate it over once, and I'm going to keep track of the smallest element seen so far in a variable called small. Okay, so initially I'm going to initialize small as int max. No, here in this case, we don't need int max. So initially, so for the first element, what's the answer? Answer is, in this case, we are asked to print 0. So if first element is small illa. For the second element, what will always be the smallest value? Can anyone say? For the second element, always the smallest value on the left is going to be what? Anybody? For the second element, yeah, it is the first element, right? So I'm going to put small as ARR of 0. Okay, this is the smallest element we have seen so far, and we are at this index. Okay, we are at this index. We are at index 1, and we have the smallest element we have seen so far is ARR of 0. So it is 0. Okay, now I'm going to iterate over this array, and at each step I'm going to update the value of small. Okay, that will give the element seen so far. So for 4, the answer is 6. We already have 6. Now you check if the current element is smaller than the already smaller element. If so, then we can update the small, right? So what we are doing is for I equal to 1, to n, we check if the current element, which is ARR of I, is less than small, then we have to update small. Okay, before that, we are storing small. Okay, we are printing the smallest element seen so far. And then if the current element is less than small, we can update small, right? Small is equal to ARR of I. Okay. So what this does is initially, when you start from 1, so for 4, it is 6. Now after this, you check, is 4 less than 6? Yes. So now I can just ignore the 6, right? For all the other elements, the smallest element is always going to be 4. We don't need the 6 anymore, right? So I can just update the smaller value and make it 4, right? Is this clear? Clear. Is the idea clear? Or if you have any doubt, ask whatever is not clear. So instead of iterating through it again, we will just keep track of the smallest element seen so far. This represents the smallest element so far. Okay. The rest of you, is this clear, the idea or the logic? I'll explain the rest of it, but type something in the chat, and the rest of you. Yeah, okay, good. Yeah. Others also? Only Kevin and Abhinav are responding. The Baki are lived in the poya. Type anything. Or if you have doubts, you type the doubt. I don't mind. Let him go in alone. Okay, right. So here, we just keep track of the smallest element so far. When we reach for 4, it is 6, and we update it. Okay, now we go to the next element for 5. For 5, the smallest element is still 4, and here we don't it doesn't get updated, right? Because ARR of I less than small is not true, so it is still 4, right? We still have, that's what I meant by smallest element so far. So the answer is still 4. So for this, you will print 4. Okay, when you reach 3, it gets updated. ARR of I less than small, so small gets updated to 3. Now this 4 or 6 or none of that matters again, right? We just take the minimum so far. So we have 3 here, and similarly the rest of the loop gets executed. Okay, so this would be the algorithm, this whole thing. And can you tell what would be the time complexity of this? Order of n. Anybody else has a different answer? Or if you have the same answer, type the same answer. Okay. Order of n. Yeah, it is order of n because you just iterating from 1 to n. Okay, and you're not using a nested loop. So when you have to find the smallest element so far, you can just use this. So I think that's what was coded. What is the code? Yeah. So the code for this would be the same thing. So in small is equal, initially we print 0. And then you have a small, in this case, I'm going to initialize it with the first value, because that for the second element onwards, it would be the first value. Now for int I equal to 1, I less than n, I plus plus. Small, you print the smallest value so far. And then you update the small as min of small comma ARR of j. ARR of I. Okay. Now some of you wrote I minus 1. So when you do that, you put this statement above this. Okay. Or if you write it in this order, then you can just use I instead of I minus 1, because first we are printing and then we are updating. Okay. And then yeah, I think that's it. No? Yeah, okay, let's try this for the other input. Anyone has any doubts on this solution? Do you have any doubts? Is this clear? Type something if it's clear, the code. Yeah, we get the output. Okay, so this is the answer and this is order of n, this solution. So as we saw before in the previous case, we used the loop, which was unnecessary, right? So we brought down our time complexity by from n square to n, and this will pass, like it won't give you a TLE. Okay, is that clear? Okay. And also those of you who wrote the Python solution, when you use list slicing, it will take order of n for doing that. So you can convert this into Python code in the same way by keeping track of a small variable. But if you use min of I to, starting of the list to I, then that starting of the list to I will take order of n time internally, because when you slice a list, it creates that it creates the copy, like all the way. It finds the minimum by iterating through the sliced part. So when you do it in Python also, you can use the same logic and then you will get order of n solution. Okay, so is that clear? And so similarly like this, I will suggest you to try this question where you print the smallest element to the right of the given array. Okay, not right now. You can try it out on your own. I think we have reached the time for this. So do try that out. And then once you do that, you can try this question on LeetCode. I'll put the link to that. This is a question which you can apply this thing, whatever you have learned. I actually thought of doing this question right now, but we don't have time for that. So like I thought of we'll do the minimum thing first, and then based on that, I'll show you this, but we've run out of time. So I will suggest you just try this out, and if you have any doubts, you can ask me, or ask in our TLE, the Discord server. So I'll just put the link in the chat. Okay. Yeah, thank you so much. So we were just able to do one coding problem actually, but I think like you saw the way in which it got optimized and all. Actually, when you do this LeetCode question, if you type that n square solution there, you will get a TLE. And so that's why the n square solution doesn't work. So you need to be able to optimize your code. Okay, so thank you so much. Please don't leave. There's something about the form. If we are doing the same question for the right side. I think you are typing something. Okay, anyway, can someone from the TC or the TLE put the link for the form in the chat? Isn't the minimum of the list the answer? No,
the
no,
original
no.
registration form?
No, registration.
The new form.
Certificate in that. One second. Okay, Kevin's doubt, isn't the minimum of the list the answer? No. What that question would be is for finding the min of each element on the right. So if I have an array, say 3, 1, 5, 2, 4, 8, then the minimum to the right of 3 is 1. Minimum to the right of 1 is minimum among these. So it is 2 and so on. Okay, so for this also it is 2. For this it is 4. For this it is 8. And the last element doesn't have a minimum. So you can put either 0 or infinity. Okay, this is the other variation of this question. This also can be done using the same logic. And same way you can find the maximum on the left, maximum on the right. So you can try all these questions. Do try them out and the optimized solution, and then you can try that LeetCode question also. Okay, and regarding the certificates and stuff, so we'll put a form in the chat. Do fill up the form and it asks you need to enter your hacker username in that. So we had conducted some tests after each session for the 4 previous sessions. So based on that, we'll be giving, like, if you had attempted at least say 3 or if you had attempted at least 3 or for all the 4 tests, then we'll give you the certificate. So do fill out that form. One of you put the link in the chat, the link to that form. Do fill the form, and then we can give you the certificates. And so yeah, this brings us to the end of